Okay, so let's continue our discussion about DC circuits. So we already answered number 3 and number 4. So let's have more example, but this time magresa ta ato ang katong mga DC circuits. So let's just answer this one about resistance dependent on temperature at saka yung uh, the definition of current. Okay, so let's answer number 5. So I just want to read this one first. So the resistance of a coil copper is 3.35 at 0 degrees Celsius. What is its resistance at 50 degrees Celsius? Okay, so sa copper na to, ang iyahang resistivity is equal to 4.3 times 10 raised to the negative 3 per Celsius degree. So you are given with the resistivity here. Okay, so this is just a straightforward na problem. So unya na ha. So we have R sub naught, then we have here we have 1 plus alpha, then next is we have delta T, diba? So your delta T is actually equal to 50 degrees Celsius. Okay, 50 degrees Celsius kasi that is final minus initial, diba? So we have final minus the initial temperature, and that is equal to 50 degrees Celsius minus 0 degrees Celsius, which is equal to 50 degrees Celsius. Okay, so the resistance of the copper at 0 degrees Celsius, or the which is the initial resistance, is 3.35. So we have to find the resistance at 50 degrees Celsius. So basically 3.35 ohms, and then we have 1 plus the alpha of the copper, or the temperature na coefficient, is 4.3 times 10 to the negative 3 per Celsius degree, and the delta T is actually equal to 50 Celsius degree, and that is equal to, how much is that one? So let me check if sakto ba ito ang, so is it correct na mao ni ato ang yeah, that is correct. So I just want to check if, so yeah, what is the resistance of the copper at 50 degrees Celsius? So we just have to compute that one. So times 50 plus 1 and times 3.35. So that is equivalent to 4.07. Okay, so that is 4.07 ohms. So meaning that the resistance increases when the temperature also increases. Okay, so how about number 6? So our resistor is to have a constant resistance of 30 ohms independent of temperature. So take note of the word independent of temperature. So for this, an aluminum resistor with resistance R sub naught A, that is aluminum, at 0 degrees Celsius is in series with the carbon resistor with resistance R sub naught C at 0 degrees Celsius. So we have to find the initial resistance of the aluminum at saka carbon, which is in series. So this is like the application of series circuit at saka yung resistance na dependent on temperature. Okay, so since they are in series, we have to assume that the equivalent resistance is just equal to the resistance of the aluminum plus the resistance of the copper. Diba? Ka in series man sila. So here, the RA here dependent on temperature. So we have R sub naught A, the initial resistance of the aluminum, plus 1 plus alpha A, the temperature coefficient, and delta T. Then we have the carbon, so 1 plus alpha C, delta T. So what you're going to do is you have to take note of the word independent of temperature. So rearranging this one, so we have R sub naught A plus R sub naught C, ako itong rearrange, plus, we have here alpha A, R naught A, then plus alpha C, R naught C, delta T. Okay? So this one is independent of temperature, and we know initially that nasa constant resistance nga 30 ohms. So meaning that the sum of the two resistor na na aluminum and carbon respectively is actually equal to 30 degrees Celsius. 30 ohms. Okay naman siya constant resistance, and this term must be equal to 0. Okay, so meaning ka independent man siya sa resistance, so it's either kani ang ma-zero or kani siya. Okay, so we have to make sure that ma-zero ni siya, so we have to let this one as 0. So we have alpha sub naught R sub naught A plus alpha C R naught C is equal to 0. Okay, what I mean here is ang delta T is na gina siya value always, diba? Pero independent man siya sa temperature, meaning that there's no increase. So this term must be equal to 0, but delta T cannot be equal to 0 because even though we increase the temperature, delta T is na siya value. Pero again, we have to make sure na dapat equal na siya sa 0. So this term, other than this one, must be equal to 0. So that's why we have this second equation. So using the equation that we have, the alpha A at saka alpha C, so we can now find the R sub naught A at saka R sub naught C. So your R sub A is 3.9. Okay, so we have R sub naught A. So I will just get the relationship between R sub naught A at saka R sub naught C. So that is negative alpha C, R sub naught C divided by alpha A. So we have negative. Then negative man ang alpha sa imuhang carbon. So this becomes positive. Times 10 to the, how much is this? Negative 3 per Celsius degree divided by 3.9 times 10 to the negative 3 per Celsius degree. Then we have the ROC. So cancel the Celsius degree. So we have to cancel put 10 to the negative 3. What is the answer? So that is equal to 0.13. So we have 0.13 R sub naught C. So this is the relationship between R sub naught A at saka R sub naught C. So we have to use this equation, the first equation that we had, this one, to find the R sub naught A or saka R sub naught C. But since your R sub naught A is equal to 0.13 R sub naught C, so we just have to substitute here the value of R sub naught A. So we have here 0.13 R sub naught C plus R sub naught C is equal to 30 ohms. Then we have 1.13 R sub naught C is equal to 30 ohms. So that is equivalent to what is the resistance of the copper na material. So 30 divided by 1.3, so that is 23. We have 23.1 ohms. Sakto ba po? Am I correct? Yes, so we have 1.13. Okay, so can I just put the 3.9 as 5 over 39 so that ato makita ang ato ang. So other than approximating to decimal place, I will just put it that way. And then the ROC will become 1 plus 5 divided by 39. So we have 44 over 39, that is equal to 1.13 man, di ba? So we just have to divide raised to negative 1 and multiply with 30. That is 27. So mas better if dilisan to siya i-approximate dili. So we just have to use 5.39. So instead of 0.13, you have to use 5.39. So that is equal to, I will just erase this one. So the ROC will now become 30 ohms times, we have 39 over 44. Okay, so the answer is 27 ohms. So this is nothing. Take a look at the difference. So masindot gid ko. Isa siya nimo i apa nang i decimal. Okay, because di na to makuha ang accurate gid niya nga number. Okay, how about the R sub not A? So we just have to use this equation. So we have 5 over 39 R sub not C. So we have 5 over 39 multiplied with 27 ohms. So the answer is, how much is that? So that is equivalent to 3.46 ohms. Okay, so yeah, that is number 6. So you just have to read thoroughly the kung had the problem before attacking it. So that is why naano siya para you have to understand muna the problem baka marong tayo. Okay. So number 7, it is desired to make a wire that has a resistance of 8 ohms from 5 cubic centimeter of metal that has a resistivity of 9 times 10 to the negative 8 ohms times meter. What should be the length and cross-section area of the wire B? So we have to find the length at saka cross-sectional area. So you are given the resistance as 5 ohms. Is it 5 ohms? 8 ohms. Okay, 8 ohms. Then we have the volume. I think this is the volume of the metal. So that is 5 cubic centimeter. And then the resistivity of that of the material. So this is rho na siya. 9 times 10 to the negative 8 ohm times meter. So we have to find the length and the cross-sectional area. So but before that, I will just convert cubic centimeter to meter cube. So we have that is just equivalent to 100 centimeter is 1 meter. Then you have to cube this one. So that is 5 times 10 to the negative 3. Diba? Is it negative 3? I mean negative 6. Okay, sorry. Okay, well, is 100 man diba? So negative 6, guys. So that is cubic meter. So next is we have to take note that the resistance in terms of length and the cross-sectional area is equal to this one. So we are given with R and we're given with rho. So what's left is L and A. Okay, so how to do this one? So we have R, 8 ohms divided by 9 times 10 raised to negative 8. But this is negative 8, diba? Then we have L over A. So this is the relationship between L over A. So instead of my other relationship. So how about the volume? Okay, so can we take the volume as L times A is equal to 5 times 10 to the negative 6 cubic meter? Because it's like the area multiplied the length of the wire. Diba? Mura siya og area sa, volume sa cylinder. And then we can find the, the length at saka cross-sectional area. So I just have to make sure what is the value of the ratio of the length at saka area. So 8 divided by 9, and that is 10 divided by. Oh, okay, it's very large. So I can just put this one as 8 over 9 times 10 to the 8. Okay, so that is the value. Then using this equation, so we can find also the L in terms of A. So L is just equal to 5 times 10 to the negative 6 cubic meter divided by A. So I would just put the value of L here. We have 5 times 10 to the negative 6 cubic meter divided by A, divided by A pag yun, which is equal to 8 over 9 times 10 raised to 8. Yeah? So we have here, divide both sides by 5 times 10 to the negative 6. Okay, sorry. Ibig na mo. So I would just put A here to here. So ito yung multiply. So 5 to the negative 6 cubic meter divided by A squared is equal to 8 over 9 times 10 raised to 8. Okay? So then we have to, using your algebra, then we have here 8 over 9 times 10 raised to 8. Then we have A, then taking the square root, so the cross-sectional area of the wire is said to be equal to, so that is equal to 5.625 times 10 to the negative 14. Then taking the square root, that is 2.4 times 10 to the negative 7. Then meter squared. That is just a unit of the area. So the length is, you just have to use our expression of length. So length is just equal to, you can either use of the equations. I will just use this one. So length is just equal to area multiply with 8.9 times 10 to the 8, and that is equal to approximately 21 meters. Okay, so yeah, that's it. That's the application of the resistance that we had on our first part on our discussion, our lecture video, di ba? So that's how you deal with problems like that. So last problem before going to Kirchhoff's law is this one. How many electrons per second pass through a section of wire carrying a current of 0.70 amperes? So yeah, so we have to assume that the current is the average current. So the current is equal to Q over T. So the current is said to be 0.70 amperes, Q over T. And how to find the number of electrons? So per second man siya. So therefore that your Q is, meaning that your T is 1 second, di ba? So therefore ang imuhang Q is 0.70 ampere times second, but that is not the, that is only the charge, which is equal to 0.70 coulomb. So that is the magnitude of the charge, but what is, how many electrons man yung gingon? So balik ta dito sa ato ang first module nga the the magnitude of the charge is equal to N times E, diba? So where E is the magnitude of the electron, and N is actually the the number of electrons. So yeah, basically we just have to what is Q? That is 0.70. So 0.70 coulomb divided by the magnitude times 10 to the negative 19 coulomb. So that is equal to the electron. So how much is the electron? So that is equal to 4.4 times 10 to the 18. Is it 18? Wait. 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 electrons per second. So it doesn't matter kung nasa negative diri kay remember that even though there is an equal amount of flow of negative and tsaka positive charges. So we can let E here as positive, so it doesn't matter. Okay, the number of electrons flowing and of 0.70 ampere is equal to 4.4 times 10 to the 8 na electrons per second. Okay, so we are done with that. So let's move on to the next slide. Okay, so this one, this is just your, ako lang siya hatag sa assignment. Pero we just have to skip that one because I think 4 examples are enough para sa makakabalo mo sa DC circuits. Okay, so you just have to use that. I would just give this as an assignment. So let's just move on to Kirchhoff's rule. So the very new na new na physics. Okay, so there are two rules in Kirchhoff's law. So why do we need Kirchhoff's law? Ngano di man ta mag-focus lang sa circuit reduction technique na which is very easy lang, di ba? Okay, so here's the reason why we need to kanang shift from another technique in where we can find the current, resistance, and voltage of a certain circuit is because Kirchhoff's rule are very flexible. Okay? Ang advantage niya is flexible siya even though naa siya kuan complex circuit. Complex meaning that you cannot distinguish anymore which is series and which are parallel. Okay? So unsa pa? Yeah, even sa other capacitors, transistors, and other circuit element, we can use actually the Kirchhoff's rule. Okay? So, but for atoa lang, we just have to focus on resistor lang sa. Okay? Kay dili man ta ka ng electrical engineer. Okay? This is just a general basic physics lang. And then one of the disadvantage lang sa Kirchhoff's rule are lengthy ang iyang math. Meaning na taas kaayo siya og math. Okay, so some Kirchhoff's rule, nag-use sila og matrix, which can be kanang, kung gusto mo, because you are a computer science student, you can use a computer para makuha ninyo ang unknown of a systems of linear equations, di ba? Using matrix. So, makabalo mo na siya. So, but we will not do that because I think it's too much naman siya for general physics. So, mula na iyang main disadvantage. So, lengthy kayang math. Okay? So anyway, so there are two rules for Kirchhoff's rule. So we have the junction rule at saka the loop rule. So according to junction rule, so the sum of all the currents coming into a junction or a node must equal to the sum of all the currents leaving to that node. So this is actually the manifestation of conservation of charge. Okay, so now, how can we initiate this rule? How can we like understand this rule? So think of an analogy as a water pipe. Okay, so diba usually mga water pipe, diba? Water. Diba, so if I have a water pipe here na connected to another pipe, okay? So whatever na imong makuha diri sa mga mass sa water, mas equal to the mass ayang makuha na to di kung ato ni sa lang i-add, di ba? So more siya ginana, pero we have to assume that the fluid or the water that is flowing here is actually ideal. So masama ng ideal nga water, ideal fluid. So ideal fluid in physics is actually there is no friction. Okay, there is no viscosity. So viscosity is actually a type of friction in fluid. Okay, kung viscous kayang liquid, then we cannot anymore use this one. Okay, kaya nga naman, kay mura bitaw og syrup. Kung ibotan nimo ang syrup diha, di ba? Okay, although mag the same lang gyud ang conservation of mass, pero ang fluid nga mo flow is not anymore like kanang steady man gud ang ideal fluid, meaning wala siya kuan ba, meaning that the water will flow together, stays together. Okay? So kung makita sila barrier, so magstay together lang gyud sila og flow mo nang ideal fluid. Pero sa imuhang viscous fluid man gud is inani iyahang profile, okay? So basically inana siya. So meaning that some of the fluid kinag-una Murag sa syrup bitaw kanang grabe kay siya kalasaw ay kanang ka concentrated. Na yung nag-una nga fluid na apoy na ulahi nga fluid or eventually mo stop because basig mag-interact sa environment with the wire, di ba? So we have to neglect all of that environmental factors or properties of real fluid. Okay, that is why this ideal. So why I actually kanang discuss this one, because we have to take note that we are only kanang focusing on steady currents. So sa mga steady currents. So steady currents are currents that are in uniform and it is always flowing, meaning the electrons are flowing at the same time. Okay, so meaning walay maulahi nga electrons, walay mag-una nga electrons, they are flowing at the same time, and at the value of the current at any point sa usa ka branch is constant. Okay? So yeah, uniform siya. Steady, and the current is not dependent on time. Okay, so dili siya mag-vary with time. So mao na ang steady current. So I think all of the lecture here about the recurrent circuits talks about steady current. Okay, so we have to assume na steady yung current. So therefore, balik ta aning junction rule. So whatever nga mosulod sa imuhang node, usually ang node man gud or junction, di ba? So junction is where there are 3 or more wires nga gamit. So I have here wire I1, then it will split to I2 and I3. So why I said nga I2 I3, because some of the electrons will go here and some of them will go here. Depende po sa resistance sa imong wire dire. Diba? So ang pasabot lang ni kuan ni junction rule nga unsay makuha nimo dire mas equal to nga makuha nimo kung i-add nimo I2 I3. Walay naulahi, walay nag-una nga electron. Okay, because they are the same. Okay? Wala po'y nag-ungot dili nga electron sa imong wire, walay mag-ungot. Okay? So dito gini sila tanan kay steady current man. Okay, kay once magud na imong ungot, that's the time that your current is now dependent on time. Okay? So yeah, I think that's the con. Then the junction rule can be summarized by using this equation. So the current that is going inside the node or the junction must be equal to the current outside ito mga current nga ni hawa sa junction, or that is the summation of all current is equal to 0. Okay, muna siya. Yeah, so next is the next rule is actually the junction rule. Okay, so junction rule is all about conservation of energy, because we know that loop rule, loop is all about voltage, and we know that voltage is directly proportional to energy. So we can think of it as energy lang, okay? So the loop rule is actually the manifestation of conservation of energy. So why do we need to conserve the energy? Because it is always nga dapat i-conserve yun ang energy. Okay, because once na i-violate nimo ang law of conservation of energy, then diha na din ta magduda sa theory, di ba? So yeah. So in a closed circuit, the algebraic sum of the potential changes encountered is 0, meaning that if naakay loop, imong i-add to tanang mga potential difference across all of the circuit element in that loop, then we will know that the summation, we will be sure that the summation of all potential difference is equal to 0. Okay, so loop is actually like closed circuit. Okay, closed na siya nga loop. So for example na ako'y circuit, di ba? So example lang na ako'y circuit dari. So na ako'y kandiha, na ako'y circuit na pod, na ako'y circuit dari, na ako'y circuit dari. So this is one loop, meaning that nibalik siya sa yung agi. So this is point A, then nibalik na po siya sa point A. So that is considered a loop. This is also considered a loop in a circuit. So basta close lang siya, closed circuit. Una ang loop. Okay? So why do we need to kanang why why that the summation of the voltage is equal to 0. Now remember that the forces inside the circuit are manifested, or actually the forces nga nag-involve here are actually kanang electrostatic forces, di ba? And we know that electrostatic forces are conservative. Okay? So, if conservative siya, then therefore, sa itong conservative gani, the work done by the electric force or the electrostatic force are actually equal to 0 when you are going back in a loop. Okay, so meaning that the voltage of each of the loop voltage changes, imo siyang i-add tanan, the work done is actually equal to 0, or the energy is actually equal to 0. Okay, so inana atuhang analogy diri. Okay, so always take note also that the current always from higher to lower potential throughout a resistor. Is always remember that na imong current yun is always from higher to lower potential, at saka yung positive terminal of the EMF source or the voltage source is always the high potential irrespective of the direction. Okay, so I will just continue discussing that one with our sign convention. Okay, so muna itong sign convention. Now, this is the sign conventions for the loop rule. Pero ang sign convention sa current or junction rule is that katong mga nisulod na current in a junction are positive. Okay, mo ni positive ni siya, kay nisulod man siya sa junction. Katong nigawa sa junction, mato ang mga negative. Okay? So that is why kung imo ni siyang imo ni siyang i-sum all of them, so summation of the current is actually equal to I1, which is positive, kay nisulod man siya sa junction. Then we have minus I2, nigawas man siya sa junction, minus I3, kay nigawas man siya sa junction, and that is equal to 0. So take note that si I1 can be rewrite as I2 plus I3. Now it's like actually balik ta sa pinakauna nga equation that the katong current inisulod ni junction is the I in, or this is the I in, di ba? Si I1 naman inisulod sa junction, and the I out is actually si I2 ug sa I3. So same lang siya. Okay, so mao na iyang rule lang sa imong junction. Pero sa loop rule, you have to take note of many factors lang. Okay? So usually kasi sa atoang loop rule, atong circuit element sa atoang Kirchhoff's rule are resistor lang ang kanang naa. Okay, so mao nang akong nakita, ako inyong makita dili kay resistor ra ang naay loop trace. Pero kung madatag higher nga mga Kirchhoff's rule, na sila mga transistor, na sila capacitor, what is the loop rule of a capacitor, and so on. But we just have to stick with our resistor. Okay? So first sa battery sa ta. So sa battery, if imong loop trace gani is actually moving in that direction. Okay? So kay sa loop manggod nato is depende na siya sa kuan ani mo. Okay, basta you have to take note lang gyud kung unsa ang direction sa imong loop. For example, kani the direction of the loop is either counterclockwise or clockwise, di ba? So depende naman gyapon nimo kung gusto ba ka clockwise or counterclockwise. We get the same answer lang gyapon. Okay? So like this one, these loops are all clockwise, di ba? Kani clockwise is a clockwise. So the current, if the loop trace, so this is the loop trace. So dili kay nagkuan man ka diba, nag-trace man ka clockwise direction nga loop. So at this source, what will happen to the loop trace will be like this one. So meaning that the loop is pointing to the positive terminal of the battery, and therefore the voltage drop or the voltage of this battery kay imong based on your loop trace is positive. Diba? Kay pointing man siya to positive. But if imong ibali imong loop trace, say ato siyang i-counterclockwise, that's the time that your loop is now going down here. So ana na siya. So meaning nag-point na siya sa negative. So that's the time that the voltage drop is negative. So it doesn't matter kung unsa ang direction sa current diri. It's either ana bang direction sa current diri or ana ba. It doesn't matter. Di siya mag-matter sa direction sa current. Mag-matter lang siya sa imong loop trace. Kung counterclockwise ba siya or clockwise, then you have to take note kung ang loop ba is pointing to the long line, which is the positive terminal, or the short line. So that's the time that you will know nga negative ba or positive ang iyahang voltage drop or voltage nga sign. Okay? So next one, how about the circuit element like resistors? So like resistor, so nakoy ginote dito sa pinaka pandari nga the current always from higher to lower potential. So what do you mean by that? So remember that the current here for this part lang, so the current is moving from higher to lower potential. So this means that this A is the higher potential with respect to B, the among resistor, di ba? And then for this one, kung ang imong loop trace gani is moving in that direction, in the same direction as your current across the resistor R, then the voltage drop is said to be positive and negative. Kaya nga naman, because the loop trace is, we know that this is the positive part or positive leg sa resistor, di ba? Is the negative leg. Kaya nag-point mo siya sa negative legs, that is why ang imuhang resistor, ay imuhang voltage drop pod or voltage sa imuhang resistor is negative. Okay, if the loop trace is in the same direction as your current pod. But if they are in opposite direction, same gyapon direction current, but the loop is in that direction, imong gi-assume nga dito ang direction sa loop, the voltage drop is positive. Kay since other than nag-oppose sila, the loop is pointing to the positive leg of the resistor. That is why iyahang voltage is positive. Okay, based on the loop trace. Okay? So sa imuhang circuit element, like resistor, mag-base sila sa loop trace. Mag-base siya sa direction sa imuhang current o loop trace. Pero sa source, just like battery here, magdepende na siya sa loop trace. So, dili siya magdepende sa current na direction. Okay, so muna siya. So, please internalize all of these sign conventions. Now, in order to solve a particular circuit problem using Kirchhoff's rule, so you have to make sure that the number of independent equations is equal to the number of unknowns. So, ato na ni siyang makarelate na tani kung mag-solve na to problems involving Kirchhoff's law. So, ang pasabot lang ana is you have to create an equation from junction rule at saka loop rule, and you have to make sure that the number of equation that you created from the loop and junction rule must be equal to the number of unknowns. So meaning that kung nakay 6 unknowns, 6 po mong equations. Kung nakay 4 unknowns, 4 po mong equations, because kung daghan mo kag equation, what will happen is malibog na kaasa imong gamiton. Well, in fact, gabalik-balik na sila. Okay? So you have to take note of the word independent equations. Okay, so yeah, and Kirchhoff's rules again is under steady state conditions, so meaning that the current is not dependent on time. Okay, so before solving some examples here, I have to show you something. So these are the tips on how to solve using Kirchhoff's law. So first, you have to draw a circuit diagram, of course, nanamigid na always, and label all the known at saka unknown quantities. Okay, so you have to take note what is the known at saka unknown so that you will know beforehand kung pila ang independent equations na imong kailangan. Okay, and then if wala gani ga-assign og direction sa current in each branch of the circuit, then you need to assign a direction yourself. Okay, so depende na nimo kung sa ang current nga direction. Okay, so we still get the same answer. Okay, you must assign if wala siya gi-assign sa problem. Pero gi-assign siya sa problem, then use lang to nga problem. Use lang to nga a direction sa current nga naa sa problem kay para di na ka maglibog-libog. Okay? So ang branch are actually consist of like circuit element or EMF source. So basically here maghimo na po kog kuan. So suppose na ako'y circuit ngayon ani nya gusto ko magkuha og suppose na ako'y circuit ngayon ani. So this cannot be solved using the circuit reduction technique, di ba? Kay we don't know if this is in series, but we don't know that if this is parallel with this because of the two sources. Okay, we know that this is also in series, so we can solve this one using Kirchhoff's rule. Okay, so you draw a circuit diagram, so label all the unknowns, and you must assign direction to the current. So masindot if kabalo na ka beforehand nga asang direction ang current. Okay, so usually the current will flow from positive to negative. So basically pwede pod inana imong current for this branch. So this is like first one branch, another branch, and this is another branch. So branch are actually divided by a junction. So this is our junction. Okay, so you can use this current. So mag-split man imong current, diba diri? So meaning that yeah, you can now assign direction of the current for each branch. So here imong current is looks like this one. So iyang direction kay ana lang, di ba? Ana yung direction. So here pud sa imong branch 2, imong direction is ana lang paubos. Ang direction nimo sa branch 3 is paana lang. Okay? So you have to assign each branch a direction of current. So pwede po di balihon. So suppose sa kaninga branch kay gusto ko paana siya. Okay, you can actually do that. Okay, depende sa imuhang gusto. Okay? So next also is you have to apply junction rule to any junctions in the circuit to provide new relationships among various currents. So of course, you have to take note what are the junctions. So junctions are the where the three or more wires meet. So these are the junction. You can call this one junction A or junction B. So using the assigned current and the convention of the current that katong ni sulod are all positive, katong ni gawas sa junction are all negative. Then use this relationship to get a new relationship between currents at junction A or junction B. So you have to provide all the relationship for all junctions. Okay, not only for one junctions. Next is apply the loop rule to as many loops in the circuit are needed to solve for the unknowns. So to apply this rule, follow the sign convention. So you have to make sure that you know what are the direction of your loops after assigning the direction of the current. You have to know the direction of the loops. So pwede ka okay mag-clockwise ako diri kay mag-counterclockwise ko. Then the gawas is considered also a loop because they are actually composed of closed circuit man gyapon. So pwede pud sa gawas kay mag-clockwise gyapon ko and so on. And then assign that this is your loop 1, this is your loop 2, and this is your loop 3. Ana siya ba? So then sa pag-trace din mo sa imong loop, depende na dayon sa sa atong sign convention nato kani. Kung pag-add nimo sa mga voltages across this loop, so we have to add voltage ani, voltage ani, voltage ani, voltage ani, voltage ani for this loop lang, loop 1. So you have to take note kung unsa tong mga cosine convention nila. Okay? So you have to take note gani kung battery always lang sa loop. Pero kung sa resistor, circuit element like resistor, you have to take note of the direction of the current port. Okay? The next one is you have to using the loop rule. So, di ba, maka-provide man ka og relationship sa imong loop rule because we have to sum all the voltages in a loop that is equal to 0. Now, there are many loops in a circuit, but you only have to take note that magkuhan lang ka og number of equation or relationship in a loop that is equivalent to the number of your unknowns. Kaya kung daghan na mo ka og equation, what will happen is maglibog na kaon sa imong gamiton. Okay? So always remember that. So next is we have to solve the equation simultaneously for the unknown quantities. Then that's the time that you will now solve the equation. So hindi na din makuan ang mga basic math skills nato like solving linear equations using elimination, substitution, and so on, di ba? So yeah, that's basic math. Okay? Then if a current na imong makuha is negative, don't worry because that means nga imong gi-assign nga direction sa current is actually balira. Okay? So balira gyud na siya. Then mao ni ang pinaka critical kaayo. Kung makita gyud kag current nga negative, ayaw sa siya ihimong positive. Ayaw sa siya ihimong positive kay kung imo mo siya ihimong positive, what will happen is it will affect your results. So it will affect the equality of the equation. So what will happen is you will still again use the current negative to find another unknowns. Okay, kasabot mo. So gamiton gyapon to yung current and negative. Then at the end dayon, i-conclude ninyo then therefore the current that I assign for R1 is negative. That means that it is in opposite direction to my assigned current. Ana dayon i-conclude din with dito. Okay, kay kung inyo mo kung i-positive ditso nga ga-solve pa mo, your answer will be incorrect na dayon all throughout. So that will affect the equations po. Okay? So the next step is kung gamiton ganito ang Kirchhoff's rules, assign a separate unknown current to each branch in the circuit. Maura gyud na. Basta ang branch kay pwede consist of circuit elements. Basta wala lay junction, ayaw pa siya. Sorry. So ayaw na siya equal. So again, the junctions are separated by the branch is actually separated by junctions. Okay, so we have this branch 1, branch 2, then we have branch 3. Yeah. Again, so you have to make an assumption kung unsa ang imong direction diri sa usa ka branch 1. So suppose mo niya kung direction sa branch 1. So ayaw ning utag sa tagsa ha, basig yung inaon nga kani gusto kong direction niya kay kani, gusto ko kay kaning direction sa usa ka R1. Ayaw na siya. That is wrong, okay? Dapat same sila og direction sa current because they're in the same branch man. Ayaw yun ana ha kay wrong yun na siya actually, okay? That is wrong. So you have to assign the direction of the current for each branch, not on each of the circuit element. Okay? Okay, so let's apply what we have discussed on the Kirchhoff's rule. So for example, find the currents I1, I2, and I3 in the circuit shown. So in the circuit shown, so we have this one, you have to find I1, I2, and I3. So first, you already given the assign of the current. So the branch kani, the branch BEFC, I will just copy this one. I will put it here para makuan gid nato nga kuanta. I will put it here. So here we have to find the current I1, I2, and I3. So the branch BEFC kana siya current na I2. So meaning that I2 is kani I2 na siya tanang diha. Mo na yung direction sa current for this branch. So for the branch BC, ang iyang current is the I1. So mo ni siya. and the branch BADC is actually for I3 ana yang gi-assume nga current. So again, kung wala gani gi-assign sa imuhang problem ang direction sa current, hindi kami mag-assign for each branch. So kung gi-assign, good ayon na lang kung ilabti. Okay? So, okay, let's answer this one. We have to find I1, I2, and I3. So we have two junctions, that is junction B at saka junction C. So what do you think are the relationship of the currents at junction B? So at junction B, ang nigawas na current kay si I2 at saka si I1. So meaning they are both negative. So this is I1. So meaning that negative I1 minus I2. Then ang nisulod ng current is si I3. So that is positive I3. And according to junction rule, that is equal to 0. Okay, but how about for junction 3? I C. So ang nisulod kay si I1 o si I2. So meaning si I1, I2 are positive. And then si I3 kay nigawas. So that is negative. That is equal to 0. Okay, so mao na ang wala man na ang loop ang junction na to. Okay, so yeah, that's all the only relationship. Next is you have to provide the loop. Okay, so depend kay wa man siya gi-assign nga loop diri, kita nga mag-assign. It's either clockwise or counterclockwise. So for loop BEFC, BEFCB, akong i-assign diri nga loop is a clockwise direction. So clockwise na ko siya. And dili gusto ko counterclockwise. So I have here 3 loops. So 1, I can assign this one as 1. I can assign this one as loop 2. And katong sa gawas, I will put this one as clockwise direction. Okay, I will assign this one as loop 3. Okay, so sa loop 1, I will assign like a we have to make a relationship between the voltages across loop 1. So the loop 1 is consist of 14 volts, then we have the 6 ohms, we have the 10 volts, and then we have the 4 ohms. So we have to make sure that the we have to sunod-sunod the sign convention. Okay, so for 14 volts, ang iyahang loop trace is going to the negative, di ba? Kaya going to negative man siya. So therefore, iyahang voltage drop, voltage is negative 14 volts. Na, okay? So next, isa pa man yung loop, kaning 6 ohms. So the current of 6 ohms going in that direction, pero imong loop is going in that direction. So the voltage across 6 ohms is positive. Okay, so meaning that we have positive 6 I1. Mo siya I1 R1 ba? Okay? How about for 10 volts? So it is again pointing on the negative nga terminal sa battery. So the voltage is negative 10 volts. And how about for 4 ohms? So the I2 is in the same direction as your loop. So the voltage across 4 ohms is minus 4 I2 is equal to 0. Okay, so that is for loop 1. How about for loop 2? So for loop 2, the circuit elements that naa niya is si 10 volts, si 6 ohms o si 2 ohms lang. Okay, so okay, evaluate. So si So si 2 ohms are actually in opposite direction ni loop. Okay, so therefore, ang voltage drop is positive. So we have positive 2 I3. The next, how about si 6 ohm? They are still in the opposite direction. Si I1 dito man, yung loop kay dito. So positive gihapon. That is 2 I3 plus 6 I1. And how about the 10 volts? So it is pointing in the negative terminal. So we have negative 10 volts is equal to 0. So we have 3 unknowns. So we need 3 equations using our loop. Okay. So next, the loop 3. So loop 3 is consists of 14 volts, 2 ohms, at saka si 4 ohms lang. Okay, wala man na-try si 10 volts o 6 ohms sa amuhang loop 3. Okay, then evaluate. So the loop 3 is pointing in this point, nag-point siya sa negative terminal, so the voltage is negative 14 volts. Here, the voltage is in the same direction as the current, so voltage ni 2 ohms is negative 2i3. How about for 4 ohms? Still negative, kay same direction man siya sa loop o current. Okay, then we are now ready to calculate I1, I2, and I3. Okay, let's do this. So here, we can use either elimination or substitution. Diba sa atong systems of linear equations. So, there are many ways to kill a chicken, pero for me, I will just use elimination for 2 and 3. So, 2 and 3. So, why do I need to use elimination? Because I want to eliminate I3 here so that ang mabili na lang kasi I1 o si I2. So, can we do that one? No, kung if eliminate na to, same lang gihapon sa agree, di ba? So, let's provide something, okay? So, ito ni Kuan, wait. Okay, how about we use the loop, the junction rule? So, the junction states that I3 is equal to I1 plus I2. So how about we use that one and put it here? Okay, so is it correct to put this here? Because we have to make sure nga duha lang ka variable sa sa two equations so that we can eliminate one variable tapos makuha na itong usa ka variable. Okay, so we have to sa equation 3 or loop 3, we can use this relationship minus 2 times I1 plus I2. So I just have to substitute 1 here. Minus 4I2 is equal to 0. Then we have here negative 14 volts minus. So can I divide by 2 para 7 volts. Then we have I1 minus I2. Then we have minus 2I2 is equal to 0. Then we have negative, or divide both sides by 1 na lang, ay negative 1. So that may mo siyang 7 volts minus 3 plus 3I2. Then we have plus I1 is equal to 0. Then we can use this equation and this equation to find I1 or I2. So we have, for this equation, this becomes, equation 1 becomes negative 24 volts plus 6I1 minus 4I2 equals 0, or we can rewrite this one as 6I1. I divide both sides by 2, then I will put 24 volts here. So we have 3I1 minus 2I2 is equal to 12 volts. Okay, so we are now done. So proceed with the elimination, I think. So first, equation 3, we know that 3I2 plus I1 is equal to negative 7 volts. Then equation 1, we know that 3I1 minus 2I2 is equal to 12 volts. So we can just multiply here by negative 3 para pag-add na to sa 3 ug 1, matangtang si I1. Okay? So we have here negative 9I2, and we have minus 3I1 is equal to 21 volts. Then for here, same lang gyapon, 3i1 minus 2i2 equal to 12 volts. So pag-add natin nilang duha, may eliminate si 3i1. So what's left is negative 11i2. Then we have here 33 volts. Then divide both sides by negative 11. So the I2 is negative 3 ampere. So una pa lang nga kuan nga current, your I2 is now negative. So anyway, just proceed with the negative. Okay, so just like what I said. Then use again either equation 3 or 1 to find I1. Okay, so I will just use equation 3. So we have 3 times negative 3 ampere because your I2 is negative 3 plus I1 is negative 7 volts. Then we have here I1. I will just put it because we have negative 7 volts minus 9 amperes. So we have here plus 9 ampere then. So 9 minus 7 is 2 amperes. So that is positive. So do not worry about the volts and ampere din naman kuan ha. Basta as long as you stick with the kuan kay volts man po ni siya kay 3 resistance din kay 3. So volts lang gyapon ni siya, so it's actually valid. Okay? Basta as long as you know the SI unit of so we have I1 and I2, but remember I3 is equal to I1 plus I2. So we have here 2 amperes minus 3 amperes is equal to negative 1 ampere. So muna kung pasabot ninyo niya na you have to make sure muna nga ang imuhang mga current kadi nimo siya i-positive dili kay once i-positive nimo it becomes 5 amperes, di ba? So it will marong na din ka. So basically your I3 and I2 are in the opposite direction that the problem is supposedly ayang gi-assign nga direction. Let's tanawon daw nito. So meaning that the I2 must be in that direction. Okay, opposite man siya. Ay, kung sagi ang, yeah, I2 is going in that direction kay opposite si I1 mo'y dako. Diba? So, pila sa I1? 2 amperes, diba? Then si I3 is negative man siya, so opposite gapon siya direction. So, meaning, opposite sa gi-assign nato na value. Okay? No, nang iyahang through nga direction sa current. Okay, so I think siya. Let's see kung sa I2 daw sa. So, naghang na akong laptop guys. So, I will just proceed to another video lang. Okay, para dili ko siya magbukat na kayo sa iya ha. Okay, so I think I just have to discuss the other problems to another lecture video. So goodbye.